Okay, so what do we do if leading coefficient or no leading coefficient, we have a quadratic, so that means we have an x squared, and we can't factor it. There is going to be that option that you have something that you just can't factor, but you still are charged with solving it. So you can solve it using the quadratic formula, even if it won't factor. So the quadratic formula does the exact same thing as solving by factoring. It finds the x-intercepts, where the graph is going to cross the x-axis, or the solutions. X-intercepts and solutions are the same things. So the x-intercepts of a graph equals the solutions. All right, so when we're looking for two answers, and remember, if you've got a quadratic, that square tells you how many solutions you're going to have. Now, when you have a linear equation, like we did in 6-2, 6-3, 6-4, and you just have x plus 5 equals, 1, and you've got x to the first power, well, then it's telling you that there's just going to be one solution. But you solve these very differently. So if it's x to the first power, you're going to use SADMAP and go through the solving equation process that we did in those three sections, 2, 3, and 4. If it's got the square, that's when you're going to want to factor to solve it, or if you cannot factor it, you're going to want to use the quadratic formula. So let's walk through the quadratic formula. Okay, it works for any type of a problem that is a quadratic. And when you see that square, you know that the graph of it is not a line, but instead it's a parabola. And we're going to deal with graphing next class period when we start chapter 7. Okay, so notice these are all different forms of quadratic equations. Well, they're all in standard form. Standard form is the highest exponent comes first, and then the no exponent comes last. Here's the formula. Now, this is not that hard to remember if you put it to music. So I'm going to embarrass myself and do this to the tune of Yankee Doodle for you. It's easier for me to do Yankee Doodle than Pop Goes the Weasel. But here it goes. X equals negative b plus or minus square root b squared minus 4ac all over 2a Yankee Doodle. Keep it up. Alright, so if you learn it to Yankee Doodle, you can remember it. And there's a couple of other tunes that you can do it to, but Yankee Doodle is the easiest. So, Pop Goes the Weasel, I don't know if I can even get the tune of that in my head. You might be able to do that a little bit better than I. But you do need to know the formula. Alright, what I want to point out is that every bit of this stuff that you see on top, it's all divided by 2a. Very often I have people try to divide just what's under the radical by 2a, but the 2a goes for both of these. So just be careful with that. Other than that, we're basically just going to do substitution. So once everything is set equal to 0, these two already have everything set equal to 0. This one does not. So make sure that you move that 14 before you start. So your clue is the x squared. If you're looking at this one and you see the x squared, you're thinking, oh, this is going to be a quadratic. So everything has to be on the same side of the equal before I can start factoring. So remember, when you move something across the equals, it's going to change its sign. So make sure that positive 14 turns into a negative 14 before you start this process. All right, so we need to know what is A, B, and C. A is always with the x squared, B is always with the x, C is always the constant. Again, A is with the x squared, B is with the x, and C is the constant. You don't want to take it on this one until everything is on the same side. But we're following the same pattern every single time. So once we do that, the only mistakes that can be made would be, number 1, not knowing the formula, and number 2, just not filling it in correctly. So let's try to find our x's. And remember, these are x squared, so we are looking for two answers. Okay, I'm going to start plugging it in. Okay, negative b, so that's the opposite of whatever your sign currently is. Plus or minus, that plus or minus is what's going to turn it from one answer into two answers. Alright, so b squared minus 4 times a times c. All of that over 2 times the a value. So that's me plugging it in. And now I just need to simplify. So let me change colors. Alright, so that's going to be 25 minus 4 times 2 is 8 times 3 is... So that's 24, 5 minus 24, which of course is 1 over 4. Alright, so in this case, I can actually take the square root of 1. What times itself gives you 1? Well, 1, of course. Alright, at this point, you are ready to split it into two different equations. So split. So we've got x equals negative 5 plus 1 divided by 4. And we've got negative 5 minus 1 divided by 4. So this is where we're splitting the plus or minus so that we can get our two answers. So that's going to be negative 4 over 4, which equals negative 1. This is going to be negative 6 over 4, which is negative 1.5, or negative 3/2. So there are my two solutions. X equals negative 1 and negative 1.5. Now, because I didn't get crazy numbers, what that means is I could have factored this one if I wanted to using divide and slide. I could have factored it. It's the one that with the crazy numbers that you wouldn't be able to divide. All right, let's do the next problem. Let me switch colors. Okay, so x equals negative b plus or minus b squared minus 4 times a times c. All of that, every bit of it, over 2 times a. Alright, so let's simplify that a little bit. Alright, so that's going to be 49 minus, I've got 3 negatives there, so that's going to stay negative. So what is that, 32? 4 times 4 times 2, 16 times 2, yeah, 32. Okay. Alright, so 9 take away 2 is 7, 4 take away 3, so we've got 17. Now that is not a perfect square. Alright, now 17 does not even have any perfect square factors, so I simply cannot reduce that any further. So if my lab asks for an exact answer, you would say x equals negative 7 plus square root of 17 divided by negative 8, comma, negative 7 minus square root of 17 over negative 8. If they ask in my lab for you to round your answer, say to the nearest 10th, well then you can use your calculator to do each of those, to take those a little farther. So I'm going to say negative 7 plus square root of 17. And now make sure that that's either in parentheses or you hit enter on your calculator before you divide by negative 8. If If not, you'll get the wrong answer. So we're going to round it to the nearest tenths place, so that is going to be 0.4. Alright, now I'm going to do the same thing with the minus. -7 minus square root of 17, enter, now divided by -8, and I get 1.4. So it's going to cross the x-axis at approximately 0.4 and 1.4. And those are rounded, so those are losing accuracy. Because they're rounded, they're not exact. If it asks you for exact, this is where you have to stop. That is without rounding. Okay, so there we go. Alright, let's do that last one. Alright, y'all, I'm going to come down a little bit and do this one. So here is 3. So A equals 1, B equals -1, and C equals -14. So I'm going to just scroll on down. Alright, so one more time. X equals -b, so that's -1. So actually it's going to end up being +1. Plus or minus b squared. So it's negative this time. So you notice I'm putting it in parentheses, so I make sure to square that -1 and make it positive. Minus 4 times a times c. All of that over 2 times a. Alright, so let's simplify that a little bit. This is going to be a +1. This is going to be a +1. And I've got 2 negatives here, so that's going to end up being positive as well. 4 times 4 is 16. So 57 up under there. 1. Alright, so now I'm ready to split 57. Does 9 go into 57? Nope, not evenly. Okay, so I'm pretty sure that no perfect square factors here, so we can't simplify it. But you should check, because sometimes you'll have perfect square factors. But there's no perfect square factors there. So if we want the exact answer, we're going to say 1 plus the square root of 57 divided by 2, and 1 minus the square root of 57 divided by 2. Because that's as much as I can simplify it without rounding. Now, if they say it's fine for me to take the answer to the nearest, I don't know, let's go 100th this time. Then I'm going to let my calculator take it a little bit further. So 1 plus square root of 57, enter, now divided by 2. So that's going to give me 4.27. And then I want to do the same thing, 1 minus the square root of 57, enter, divided by 2, and that's going to be -3.27, rounded to the hundredths place. So again, I'm losing accuracy when I round. It's not exact, but it's a good approximation. Depends on what you're doing, how exact you want to be. Alright, and there you go. That's how you use the quadratic formula. Alright, so what if you're working and you get a problem that does have a radical with a perfect square factor, like this one? Let's do this one. Alright, so I've got x equals 3 plus or minus the square root of 75 over 5. But you've put that in my math lab and they're telling you that you're not simplifying it. And you're like, okay, so that means I can go a little bit further. What that means is 75 has perfect square factors. So here it is again. This is what you learned in section 5-4, simplifying the radical. So let's go back and think through simplifying the radical. What is a perfect square factor inside of 75? Okay, so let's see if I can go back there for you. 5-4, here is my chart. of perfect square factors. Let me take all that off. Remember, we said don't worry about 1 because it doesn't help anything. But looking in the white, those are our perfect square factors. Now, 75 would fall right in here. So that means it's got to be less than. It's got to be one of these numbers. So you want the biggest number that you can possibly get. 64 does not multiply to give you 75. 49 does not. 36 does not. But ding, 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 25 times 3 is 75. So we want to use that to simplify the radical. All right. Okay, so I'm going to rewrite that. 25 times 3. All right, and I'm going to come over to the side and say, okay, that's 25 times 3 in their own separate radicals. All right, so the square root of 25 is 5. The square root of 3 we cannot simplify any further. So that's what it's going to simplify down to. So I've got x equals 3 plus or minus 5 on the square root of 3 divided by 5. All right, so let's split that up. X equals 3 plus square root of 5 over 3 divided by 5. Oops, just kidding. You see it. I didn't mean it. Okay, and 3 minus 5 on the square root of 3 over 5. All right, now some of you are probably noticing those 5s and you're really wanting to cancel them out. Well, you can if you want to, but I need to remind you that this 5 goes to both of these, not just the second term. So if you do cancel that out, you've got to do it this way. All right, so the 5s would only cancel out on that side. So 3/5 plus or minus. Let me just show you. It would cancel out there. So then you would still need to write it this way. So this is your exact answer. All right, let's do our rounded answer. Where is it actually crossing the x-axis if we were graphing? All right, so 3 divided by 5, enter, plus the square root of 3. So 2.3 rounded to the 10th place. 3 divided by 5 minus square root of 3. So negative 1.1 rounded to the 10th place. So here's your rounded answer. That's where it's crossing the x-axis approximately. Here's your exact answer. My math lab will tell you beside the blank, do they want an exact answer or do they want a rounded answer? And if they want a rounded answer, they will tell you what to round to. So there you go. That's how to solve an equation that you cannot factor. But a reminder, even if it will factor, this method will still work. All right, y'all have a great day. Start chapter 7 next time I see you.